All right, I thought I'd do a quick run through of these vortex aerators I've been working on. Um, this is the first generation version. Um, Based on Victor Schauberger's work for vortexing, trying to use some of those ideas to increase dissolved oxygen. This first version, it's got that same kind of, what do you call that, parabolic or elliptical cross section. And then in this input side, there's the output side, I'm trying to induce a vortex in this guy. And there's supposed to be a pressure drop occur in the center there, which is supposed to pull air in through this third leg. Focus. There we go. But yeah, it's very difficult to do some of this stuff in molding, so 3D printing makes it possible to make some pretty exotic parts. But since I was not getting the pressure drop that I expected out of that version, I saw some stuff that other people have done. I think maybe they're in Sweden. So I thought, okay, let's try that technique. I need both hands to do this. Yeah. See if I can get it. Oh, darn. Darn. Bear with me. Alright, here we go. I got a list. So this one, same component that was on version 1, didn't change anything there. Put a little rubber O-ring in there for messing around with some other stuff. This one, the shape changed some. Still have this place where I was hoping that it would induce airflow. Keep breaking my hose barbs off though. I can't print hose barbs very well. Very small there. But anyway, you can see here I've got something a little different going on. Ew, looks like I got some algae growing in there. And I'll have to use my hook to pull out that third component. Ew. So there we can see. So I've divided this up into parts. So this is the housing. I can get an angle where I can get some light in here. There's a little rim down there that the core sets on. And here is the core. You can see it's got some interesting stuff going on here. I may have to turn on NX to show you what exactly goes on. Water goes through the middle there, and it goes in kind of a plenum region here where there are 4 twisted paths that come out around the perimeter down here and create the vortex. And then air can come in, and there's a lot of slime on there. Air comes in through the center hole. Should have washed this before I tried to record this. Air comes in through the center hole, which gets in between these ribs. As you can see, I may have to try on NX to give you a cross section how that all works. And I may not be getting a good enough seal. There could be several things going on here that I'll have to work on to see if I can get this thing to optimize. But what I have seen is you can literally fog the water with microscopic dissolved air bubbles, which should do wonders for your dissolved oxygen in a very small space. And my intention for these is to put them just on the end of a half-inch vinyl tubing, and so I can divert some of the flow from my pumps that's going to my highest hydroton beds up to or down to these deep water beds to aerate the roots for those plants. And also I'll be having shrimp living underneath there. I've been making all these components with my Markforged printer. There's the internal part view. But this is as separated as individual components. I can show you an assembly in NX later. Anyway, that's what we're doing here. Oh, here you can, of course, see some of the other components I've been making. Here is my vortexing standpipe, which is so simple and working so well. I'm just really, really impressed. I have two versions of this. One that's got a 3/4 MNPT connection for going into standard bulkhead fittings, and this one that just goes in over 3/4 ID PVC pipe, so you can make that an adjustable height. So whatever size grow bed you've got, you can make that work for deep water stuff to help aerate tanks. Here is one of my bell siphons that is attached to a bulkhead fitting. Even though it can act as its own bulkhead fitting, I am appreciating putting in a proper bulkhead fitting, because if you have some emergency in a grow bed and you need to cork something up and change something to make a repair, it's a very good idea to have that. Otherwise, you can back yourself into a corner. Anyway, next iterations on this guy are going to be, I'm going to make some taller ones, which I just got a case of these new bottles in that are much taller than my old ones. So if you've got, grow beds that are, 12 to 15 inches deep that you want to put bell siphons in for ebb and flow, then that will be possible. And of course, it includes this ring that supports your PVC 3-inch diameter PVC shroud to keep hydroton out of your bell. The latest versions of this are getting more and more interesting because I've added this vortexer inside of the downpipe. Ugh. Focus. Now I understand ABE why he swears so much. There we go. Siphon breaker, a lot of little features included into this thing. This one is not the latest. The next one also induces a vortex here, and I had to open it up because it was starving the downspout or the standpipe for enough flow. When I went and changed this and made the overall cross-sectional area bigger at the bottom, it was sucking more than could get through these holes down here. So I had to go back and recalculate and make those taller, and I angled them to help induce a vortex once again going down that standpipe. I don't know that it helps because there's not a lot of oxygen inside of the bottle once it pulls vacuum. But, what the heck. A vortex is a vortex, right?